Hi, this is Ms. Trevino, and I'm going over the Unit 4 and 5 for the 2020 Physics Midterm Study Guide. I already went over Units 1, 2, and 3 in earlier videos, so if you have questions about those, check on the previous videos. So I combined Unit 4 and 5, the forces, because we're not really going to focus on universal gravitation as much as we are as the normal forces here on Earth. Number 37, friction always acts against the applied force. So it always opposes motion. Meaning it's always going to go against your motion. So whichever way you're pushing or pulling something, friction is going to act against that. 38 through 41, we're going to match the following forces to their correct definitions. Number 38 is a normal force. A normal force is going to be the upward force that's perpendicular to the surface of the object. So again, if this is the surface, the normal force would be up like that. So 38 is D. Number 39, friction force. Again, it opposes motion. So this one is the resistive force that occurs when two surfaces slide across one another. So it's always going to act against it. It's resisting. 40, tension force. That's going to be a force that is transmitted through a rope, a string, a cable wire. And finally, applied force. That is going to be your push or your pull. Number 42, what is Newton's first law of motion? Define and give an example. So Newton's first law of motion states that an object in motion will stay in motion, or an object at rest will stay at rest. Object in motion will stay in motion. An object at rest will stay at rest. So an object in motion will stay in motion, an object at rest at stay at rest. An example will, that could be anything, honestly. It could be you walking. Can't spell you. You walking when you're in motion until you stop. Or you sitting. You're sitting down until you stop. What is inertia? Inertia is basically the laziness. It's the object's ability to resist a force. So it's an object's resistance to a force. Remember, it's the laziness. Objects are being lazy. Number 44. What is Newton's second law of motion? Define and give an example. Well, Newton's second law is just that the force of an object is equal to its mass times acceleration. So if we increase the mass of an object, the force will increase. If we increase the acceleration of the object, the force will increase. And Newton's third law. For every action, there's an equal and opposite reaction. For every action, there is an equal and opposite reaction. And an example for that can be you push on a basket, a shopping cart. You push on a cart, and the cart will push back on you. Number 46. An object is accelerated at 6 meters per second by a 10 Newton force. What is the mass of the object? So let's look at everything we know and we want to know. We want to know the mass. We know that an object is accelerated at 6 meters per second squared by a 10 Newton force. So that is our acceleration, and that is our force. We're looking for mass. We have acceleration and force. We're going to use the first formula, force equals mass times acceleration. We're just going to have to rearrange it. Force equals mass times acceleration. So our force is 10. Mass is what we're looking for. And acceleration is 6 meters per second. All you need to do for this problem is just divide both sides by 6. That cancels out over here. So 10 divided by 6. That's going to be 1.66667. So our mass is equal to about 1.67 kilograms because mass is measured in kilograms. Number 47. A very massive object A and a less massive object B move towards each other under the influence of mutual gravitation. Which force, if either, is greater? So this one is a trick question. We have a bigger object A and a smaller object B. Which force is greater? So this deals with the rule of universal gravitation and Newton's third law. These forces are equal. So the force you're pushing on one object is the same force the object is pushing on the other. The only thing that's not equal is the acceleration. Obviously, the smaller object's going to go faster and the larger object's going to move slower. But the forces are always equal. Again, that relates to Newton's third law. There is an equal and opposite reaction, meaning there's an equal and opposite force. Number 67, a 67 kilogram object, number 48 says a 67 kilogram object has a force of 300 newtons applied to the right and a 200 Newton force applied to the left. What is its acceleration? So this one we have to draw it out because we have two forces going on here and we have one mass. So this is my object. It's 67 kilograms. It has a force of 300 newtons applied to the right. So this is my right direction. That's 300 newtons. And 200 newtons applied to the left. Now we want to know acceleration. So if I have 200 going to the left and 300 going to the right, my net force, which is my total force, is going to be 300 minus 200. So my net force, my total force, is 100 newtons to the right, which would be a positive number, since force does care about direction. Now I have my force, I have my mass, I could find my acceleration. I'm going to use the same formula, F equals ma. I'm just going to have to rearrange it to find my acceleration. So F equals ma. My force is 100. That equals my mass, which is 67. And I'm looking for my acceleration. To solve this problem, all I have to do is divide both sides by 67. So 100 divided by 67. That's going to give me 1.4925, or we'll just round it to 1.49. And my units are meters per second squared. That is my acceleration. Okay, let's go to 49. The figure shows a block that is being pulled along the floor. According to the figure, what is the net force acting on the block? Again, my net force, that's my total force. So I have 500 newtons being pulled to the right, that's my positive. And then I have 2 newtons going to the left, so that's my negative because it's opposing. 50 minus 10, 40 newtons is my net force. What is the acceleration? Again, I'm going to have to use my formula. F equals ma. My force is 40 newtons. My mass is going to be 20 kilograms based on the picture, and I'm looking for my acceleration. To find acceleration, all I have to do is divide both sides by 20. That cancels out over here. 40 divided by 20. My acceleration is 2. My units are meters per second squared. Number 51. What is the general term given to a push or a pull? Hint, the symbol is FA. Again, that A is going to stand for applied force. That is going to be your push or your pull because it's being applied to your object. Number 52, a physics student hits a softball with a bat. Describe the force interaction using Newton's third law. So again, using third law, for every action, there's an equal and opposite reaction. So what's going on is the student hits a softball with a bat. So we have the softball hits the bat. But because of every action, there's an equal and opposite reaction, the bat hits the softball. And again, their forces are going to be the same. The force that the softball hits the bat with will be the same as the force the bat hits the softball with. Of course, the smaller mass is going to have the bigger acceleration. The bigger mass will have the smaller. But again, same force. Number 53. An unfortunate bug splatters against the windshield of a moving car. Compared to the force of the car on the bug, the force of the bug on the car is the same. Another trick question. Remember, with Newton's third law, for every action, there's an equal and opposite reaction. Forces are always equal. I can't stress that enough. The force of the car, force of the bug. Again, the acceleration will be different. Obviously, the bug is going to feel a bigger acceleration than the car because the bug has a smaller mass than the car. All right, number 54. What is the net force necessary to accelerate a 5 kilogram mass to 32 meters per second in 7 seconds. So we're looking for the force necessary to accelerate a 5 kilogram mass to 32 meters per second, which is a velocity, in 7 seconds. So this one is a 2-problem question. We're going to be using 2 equations. To find force, we're going to need mass times acceleration, but we don't have acceleration. So first we need to find acceleration. So the first thing we're going to do is acceleration equals velocity over time. Could be VF minus VI, but we're going to assume that initial velocity is 0. We're going to assume it was at rest first, then we're going to accelerate it. So that is just 32 divided by my time, which is 7 seconds. So 32 divided by 7, our time is 4.57 seconds. I'm sorry, our acceleration is 4.57 meters per second squared. That's not our answer, that's just our acceleration. Now we can use this to solve for force. Force equals mass times acceleration. Our mass was 5. Our acceleration we just calculated was 4.57. So 5 times 4.57, it's going to be 22.85. And since we were finding force, our unit is newtons. And the last question for unit 4 and 5, safety restraints in a car helps prevent passenger injuries that would otherwise occur as a result of passengers remaining in motion during a car's abrupt stop. Which of the Newton's laws predicts that an unrestrained moving body will continue to move? Well, we have 2 scenarios going on again. We have a person in a car and another person in another car. One has a seatbelt, one does not have a seatbelt. So if they're moving and suddenly out of nowhere they stop, well, the seatbelt stops the person from moving, but the person who's not having a seatbelt still wants to go forward, so he'll fly out the window because he's still moving. And that deals with Newton's first law. Because an object in motion wants to stay in motion. That's why it's very important to wear your seatbelt. If you have a seatbelt on and you come to a stop, you won't feel the push forward as much as you normally would. If you weren't wearing a seatbelt and unfortunately you got into a car accident, you would go flying forward because nothing's holding you back. So that's all I wanted to talk about for units 4 and 5. I will make one more video explaining the answers to the unit 6 portion of your review.